Hello everyone, and welcome to the next installment in the series of Making a Game in VR. My name is Noli, and today we're going to be giving our player the ability to teleport. What you see here is the end result from what we will accomplish in this video. Everything shown will be available to you on the public repo we have in this project. Check the video description for the link. So with that, if you have trouble following along, you have the original project for reference, as well as to get the assets that I'll work with. So you may want to download it ahead of time so you have access to those specific assets we will use for this project in this video. This is my first programming tutorial on this channel, so I'm going to structure it a little different than I had initially planned, since it would have taken too long. Since I wanted to keep this video as compressed as possible for you all, so you could get the full base of knowledge and the process in a quick enough fashion, this will be how I plan to do the programming videos going forward. If you could provide feedback in the comments on if you like this format, or if you think it should change, please provide suggestions so we could possibly change the format for the next video. Without further delay though, let's jump into this video. Create a scripts folder, and inside of there, right click, and let's create a C# script. Name it Bezier. Open that up. We will go forward by pasting in a region. You should pause the video and catch up to what is going to be written out. Once you've finished that, unpause and we will begin discussing it. And then we just rinse and repeat that style until the script is complete. So let's go over our variables. Acknowledged layers are going to be any layers we want our cast to have interaction with. Our desired layer is the layer we can teleport onto. Distance is going to be the length we can travel. The visual height is best visualized as the distance divided by 3 for the line's curve. The contact material is our material of the line of our desire when we're connecting to our desired layer. The no contact material is our material of the line renderer if we are hitting the anything but the desired layer. Has finished casting is for our teleport class to utilize. The endpoint is our stored raycast hit dot point. The normal is our stored raycast hit dot normal. The line renderer is of course our visual component. The locked out zone is for letting us know when to switch the line renderer materials. Endpoint detected is for knowing when our cast has connected with the acknowledged layers. Surface angle is the degree at which we want our teleport to be allowed at. Teleport scroll speed and offset are for UV scrolling of the materials. Position segments, or pose segments, is for the amount of positions we will allow our line renderer to have. Higher value smooths the curve, but at the cost of performance. Control points are our 3 defined points that dictate the primitive shape of the curve. Moving into our functions now, toggle draw is for our teleport class to enable our line renderer. Update control points is going to be where we define the locations of our 3 control points from the origin point or the hand. Calculate Bezier points. This formula is used for our assignment of the next point in the segment of positions composing the curve in the draw curve function. Draw curve allows us to control the segments making up the curve. It constantly works with the previous segments to the next segments in harmony with the check collider intersection function to allow for not only a smooth, accurate curve, but one that casts from those segments to allow the curve to have very accurate stopping with intersections or obstructions. For check collider intersection, if we hit the desired layer and the surface angle is going to be acceptable, we are able to assign the proper material and say if we could teleport there. If we hit anything that is not the desired layer, or if the surface angle of the object is too high, we allow ourselves to then know it's locked out, so our visuals can convey that information. If we return nothing, then we also visually convey that as well by changing the material. Next, we move into start, update, and late update. There isn't much to say here. In start, we're just initializing the desired components and values. In update, we're just running what we need to have this function. Lastly, in late update, it's managing the material swapping and UV scrolling for our teleport materials. That sums up the Bezier class. Let's navigate back into our project window now. Navigate back over to your scripts folder inside the project. Let's go ahead and create 4 new classes. The first is going to be called Input Manager. Create another script. We'll call this Weapon Manager. Next is Teleport. And lastly, Player Manager. Once you've made all those, open them all up. Once your scripts are open, navigate over to the Input Manager class, and let's discuss. The button held function is going to allow us to know when a button is being held down. Our button pressed is going to allow us to know when a button has been pressed down. The button release allows us to know when a button has been released. Lastly, button squeezed allows us to check the control state of a button, such as a trigger, and read its floating point state. Once you've gotten down the Input Manager, we will now navigate over to the Weapon Manager class. Is right-handed is for right-hand dominant people. Is left-handed is going to be for left-hand dominant people. The restrict teleport will do exactly what it says and will stop the player from being able to teleport. The right and left hand anchors are, of course, so we have reference to our hand objects. Once you've gotten down the Weapon Manager, let's navigate over to the Player Manager now. The Player Manager is just going to be our reference sheet for other classes to capitalize on. The main classes we're going to be referenced will be stored here for ease of other classes to utilize. So our Input Manager, Weapon Manager, and Teleport classes will be here, and later classes will join them as we get through this series. You want to go ahead and navigate over your Teleport class now. The Teleport class is going to be where everything we just created culminates together. For our variables, teleport delay amount is the length of delay between how often a player can activate the teleport. Teleport delay is the delay timer variable. Player height is for how high above the hit dot point we raise the player. Analog magnitude is for designating how much the player needs to have pressed down on the analog control or thumbstick before our directional arrow will register. Teleport enabled is for acknowledging the state of the teleport. On button released, press amount, and on cooldown are for controlling toggling of the analog button pressed in sequence with our delay. Bezier reference is so we can access the logic in the Bezier class. Path clear object is what appears at our endpoint from the Bezier for connecting to the desired layer. Path obscured object is what appears at our endpoint from the Bezier for not connecting to the desired layer. Directional arrow is our visual for controlling the orientation we want to teleport with. OVR input references are for the controller and input designations based off our dominant hand. Player Manager is a reference point for all primary classes associated to the player to be located for easy access. Camera pivoting and updating teleport enabled. The camera pivot function allows our player to make 45-degree pivot turns. We snap the rotation as that makes people less dizzy compared to a smooth pivot. Update teleport enabled is simply controlling our delay timer and input to manage the cooldown. Handle teleport. This function handles what needs to be done with endpoints. If the zone is locked out or not, controls the directional arrow activation and orientation. It's just a lengthy housing of enabling, disabling, and positioning of the endpoint objects for the different states the teleport could be in. Teleport to position is simply called to set the root player to the teleport point with the added height modifier. Toggle teleport on activates our teleport and line renderer. Toggle teleport off turns the associated teleport involved values off after either a successful or a failed teleport attempt. Has controller is simply where we check if we returned our controllers or not based off our desired controller at the time. Controller to world matrix, touch and touchpad 2D, as well as touchpad direction all tie together. The matrix is getting the orientations of our desired controller to simulation space. From there, we plug that information into our touchpad direction, which then draws on the touchpad 2D to get the analog thumbstick X and Y information, so we could use that to base our teleport rotation off the directional arrow object that we control. Start and update. In start, we're simply setting the desired states we want for the objects and references early. Inside of update, we're controlling our needed functions, as well as changing inputs and parents based off the player's dominant hand setting in the weapon manager. That wraps up the teleport class. Now let's navigate back to the project window and wrap up things there. Alright, let's jump into our scene view, work with our hierarchy, and then inspector values, and we'll be all done here. So, navigate to your hierarchy, right-click your OVR camera rig, and unpack your prefab so we have an easier time working with all this stuff. Create an empty child to that OVR camera rig, unchild it from the OVR camera rig, and child the OVR camera rig to that empty object. We'll now call that root object the player. On that object, attach a couple classes. Start with the player manager, weapon manager, input manager, to lastly the teleport class. Create an empty child of the OVR camera rig, name this Bezier, and attach that object. In doing so, it will automatically attach a line renderer as we've required that component inside of the class. Navigate over to the resources folder and right-click and create a materials folder if you do not have one already. Right-click, create a new material, and we will call this contact material. And the type of material we're going to be using for this is going to be under the legacy shaders, under particles/additive. Let's just set up a quick color real quick. Okay, so we set up our tint color. We've attached the default Unity particle texture. Once you've created this, duplicate it, rename it to non-contact material, and let's just change the color. We now have our contact and non-contact materials. Slot the materials we've just made inside the Bezier class reference point. So contact material, go to contact mat, and non-contact to no contact. Go ahead and create a new layer. This is going to be for our teleport layer. I've already created one on layer 9 called teleport allowed. Create one of those now. Navigate back over to your Bezier object. On the acknowledged layers, go to default and teleport allowed. The acknowledged layers are going to be any kind of layer we want any form of interaction with, whether that's for allowing teleportation or for not. The desired layer is going to be for what we just set our desired teleport layer to. So that's going to be layer 9, or the integer value to the left of the string you just plugged in. Distance, we're going to use 9, and visual height will always be distance divided by 3, which comes out to 3. Let's set up our line renderer visual just real quick. Okay, so we've now finished setting up our Bezier object. Let's now navigate over to our root player object. Under the Weapon Manager class, set whatever your dominant hand is. In this case, mine is my right. Leave Restrict Teleportation alone, and then under right and left hand anchor, make sure you child the left controller anchor and right controller anchor, not the right or left hand anchor, but the one with the controller in the name. Once you've set up the Weapon Manager to the states it needs, let's finish up the Teleport class. Our delay will be 0.45 seconds. Now we need to create our game object visuals. Under the OVR camera rig, create an empty object. This will be called Teleport Success, and then we'll add a little reminder to ourselves called Disable at the end. This allows us to know that we need to leave this object disabled natively. Set the rotation to -90 by -180. Create a child of the Teleport Success. We're going to name this Center. Let's set its Z position to 0.025. Its rotation on the X will be -45, 90, and 90. We will create another child of the center object, and we will rename this to Visuals. Set the Visuals Y position to -0.005. Set its local scale to 0.15 on the x-axis as well as on the z-axis. Create an empty child of the Visuals object. We will call this Rune Decals. Set its x rotation to 90 degrees, its local scale on the x to 4, and its y local scale to 4. Let's navigate back over to our project inside of the Materials folder and create a new material. We're going to call this Rune Decal Open. This will be Particles Standard Unlit. For its rendering mode, we're going to be using Cutout. For its color mode, we will use Additive. It'll be two-sided checkboxed. For its albedo map, navigate over to your textures folder. If you haven't already downloaded the project from the repo, it's good to do this at this time so you can get the assets that I used for our visuals. If you don't want to use our assets or the visuals we have here, go ahead and just use your own textures and then just plug them into the same format I will use for what I'm going to do. So back to the Rune Decal, let's drag the Rune Decal texture onto the albedo map. Let's change its HDR color to something like our Bezier. After you've successfully created your Rune Decal, duplicate it and create another one called Rune Decal and just call it Blocked. Use the color for the non-contact Bezier onto this. After you've done so, you now have your two different versions for your endpoint center for when you can teleport and when you cannot. Navigate over to your Rune Decals object, and we need to add a couple components. First, add a mesh filter. And for the mesh filter, search quad. The next component we're going to be adding is going to be a mesh renderer. For its material, slot the appropriate material. Since this is Teleport Success, we want the successful visual. Once you've successfully created your Rune Decals, duplicate it and rename this one Cracks Decal Navigate back over to your project window inside the materials and duplicate one of the rune decal visuals. Rename this to just have cracks at the start of the name instead of runes. For our maps, we're going to be changing those only. So we're going to use our cracks decal and drag that into the maps. Once you have that, do the same process for the red version. If you slotted the cracks onto both materials, now slot the reference inside of the mesh renderer for the cracks decal. Since this is our teleport success, slot the appropriate material. Now, to get your crack visuals inside of the ring itself, let's change the local X and Y scale. So for the X-axis, we're going to say 2.57, and for the Y, we're going to say 2.65. At this point, the teleport success object is now complete. Let's duplicate it, and we're going to call this teleport failed. Disable the teleport success object. Navigate over to the duplicate objects, rune decals, and cracks decals. Once you've done so, make sure to swap out the materials for their duplicate counterparts. So for rune decals, we will use the red version. Same for the cracks. Once you've done that, disable this object, duplicate it. We're going to rename it to directional arrow. Now, navigate over to the directional arrow's first child, center. Reset the transform, and then just change the Z position to 0.02. Delete anything under the visual's child of center, so cracks and rune decals will be deleted. On the visual object, let's set our orientations. So 0, 0.055, and 0.001 for the axes positions. The rotations will all be zeroed out. For the X and Y scale, we're going to say 0.12. And then the Z scale, we could just put to 0. On the visual object, add a sprite renderer component. Once you've done that, let's navigate back over to our project folder, to our materials folder, and duplicate one of the rune decals. We're going to rename this to directional arrow. The particles standard unlit material will be used for this as well. The rendering mode is going to be changed over to additive. The color mode to multiply. For the maps, search noise. For the color, we're going to be using a gold. Once you've done that, slot this material onto the sprite render materials. Now add the sprite for the arrow. If you go back to our textures folder, this is one of the assets we're going to be using for this project. If you haven't downloaded from the repo yet, I advise you do so, or use your own as a substitute. We drag this into the sprite slot, and then combine with the directional arrow material, we get this now orange to gold glow. Once you've finished the directional arrow object, disable the object. Navigate back over to your player object, and now let's slot these objects. On the teleport class, under path clear object, we will slot teleport success. For the path obscured object, we'll slot teleport failed. And lastly, for directional arrow, it's directional arrow. Or directional object, I should say. Save your project. At this point, if you haven't already, create a quick default scene with primitive objects and materials if you'd like, so we could test this teleporting out. Okay, hopefully at this point, you've set together your scene. Whatever your floor is, or any slopes, make sure that if you want them to be teleported on, you change their layer to teleport allowed. If you want any other form of interaction, but not teleport on, make sure it's left at default. If you don't want to use default, then just make sure inside of your Bezier you create more layers to be acknowledged, because the Bezier is only going to have collision detection with the checkbox layers you assigned here. If you've done everything properly so far, it should be up and running. So now, let's go inside and play with our headset. Currently, I have my headset on now, so we should be able to camera pivot, as well as enable our teleport, control our directional arrow, not be able to teleport up a certain surface angle that is too high, be able to go up and track slopes that are under the surface angle requirement, Okay, so I've taken off my headset now. Let's exit play mode. So that was the end result of what we should have gotten today. If for some reason you're running into compiler errors or other sorts of problems, either download the project repo if you haven't already, so you could get the updated version of what's currently in this project that's up and running right now, or leave a comment below if you have any other questions or suggestions for following videos. The next part in this series will be the modeling, unwrapping, and rigging for the hands we're going to be using in this series. This will be done over on Chadwick-Oeasy's channel, or you could just favorite my playlist to follow this series as it develops. The tutorial will pick up back on my channel once Chadwick-Oeasy and StashOG finish the hands we're using, at which point we'll jump back over here to be integrating them into the project. If you like this video, please leave a like, hit that notification button, and let me know what you thought of this video in the comments below. I hope to see you all in the next one, and until then, see ya.